We got three sum closest. Given an integer array nums and of length n and in an integer target, find three integers in num such that the sum is closest to target. Return the sum of the three integers. You may assume that each input would have exactly one solution. So I feel like most of the logic here is going to be very similar to our solution for three-sum. Three-sum, the difference is that you're finding all the sums that add up to 0 and you're returning all of them. This one, you're just getting you're given a value target, and you had to find the one closest sum. So what we're gonna do is first, you can think so the intuitive solution would be to just do a triple nested loop. Just have a pointer to the first one, a pointer to the second one, and a pointer to the third one, and you just iterate through. But the problem is that this takes up n to the third time, because for every value you're iterating through the entire array essentially, and then for every for every value in that iteration you're iterating through the entire array again. So it's n3, which is just too much. It's costly. We're gonna just steal our approach from three-sum and just try to edit it. So three-sum closest works like this. We sort the array first, and that only costs us, for the record, Python sorting is O(n) log n, which really is not that costly compared to especially the O(n) to the third. And since it's in line, it's not like grouped up with another loop. Really, this probably is going to be negligible. It's not really going to play a factor, because like, you know, even if you have two O(n) algorithms, that's like O2n, and that just is O(n). Those aren't really factors when you consider complexity. You're not really worrying about the linear rate, or the the constant. Like, you know, you can take those out. Any constants just boil down to one. So if you have if you have O3, it's O1. If you have O3n, it's just On. So what we're gonna do is we sort it, and then we iterate through the first number, and then we use a two-pointer approach for the second number. That way we can just have a doubly nested loop instead of a triply nested loop, because we're having two pointers and then they are edited in the same loop. So we set a lower bound, the being the lowest possible remaining number in the array, and the upper bound being the last possible number in the array. And we check to see, okay, is the sum greater than 0? If so, then lower the upper bound. This is the beauty of it being sorted, is that we can just move these indices, and we know that we'll be going in the right direction based on that, because we can't lower L. We had to either change L or R. We can't lower L because L, we would have already, we'd either be going backwards and going towards the first pointer being the main loop, or we'd be, well, yeah, basically you just had to lower R. Or you can up L if it's too small. Otherwise, you append the, otherwise it is 0, and you append that to the list of answers, and then you iterate through the duplicates by just skipping through, by like going through L, by increasing the L index as long as it's the same as it was before, because it's not going to cause any difference. I actually don't think that we're going to do that for this algorithm, but yeah. So what we're going to do is we're going to just change this so that it returns one sum that's the closest. So we're going to change this into a sort of King of the Hill style method. So how are we going to do this? Well, we need to choose if we're going to do a king of the hill thing, we need to choose an initial value to be set as the content, like the current closest sum. Because if it's ever what was it? We need to compare every succeeding value with that. So we need to have some initial value to compare it to. So why not just choose the first one? In most other algorithms, you could do something like, like let's say you're trying to find like the max value. You could use something like -1, provided you know that all the other numbers are going to be greater than -1. But this one, it's really hard to do a minimum one because really, you're never guaranteed that whatever value you set it to is going to be less than um, the well, yeah, you're never guaranteed that whatever value you set it to is going to be less than um well, like that the values in the array are ever going to have one that's less than whatever you set it to, unless you do like infinity, but that's just kind of messy. And even then, you could just have an array full of infinity or whatever. I don't know. Okay, so the cleaner way to do it is just choose the first set of three numbers and have that be the closest sum just right off the bat. Yeah. Okay, so let's see, we have this loop right here and this loop right here. Iterates through, skips through a loop if I is the same as the last one. I don't think that's going to play a role here because we're not worried about duplicates now. We're just trying to find the closest possible thing. But then again, if you do have a duplicate, it's going to be the same answer. So we can skip through duplicates because it'll just waste our time. Okay, so first we need to set the closest sum is equal to well, it's guaranteed to be at least 3. We could just take 1, 2, and 3. We could. I'd rather just do, like, basically have the first value be, like, the first value that we would check in this sequence, because I don't want to mess with it, and even though it's a little bit redundant, it's just one iteration. So we're going to set the closest sum equal to nums 0 plus nums 1 plus nums length of nums minus 1. Because that's essentially, because remember, I starts at 0, and then we set L equal to I plus 1, so that'd be 1, and then R is length of nums minus 1. Okay, now we just need to change these conditions. Okay? So if S, if the absolute, because remember, we also, these values might be negative, so we need to get the distance between the target and the current sum. So if the absolute value of S minus the target is greater than the absolute value no, that's not right. We'd actually just have this be the target, and we'd have a separate condition to check if it's also the closest sum. If absolute value of S minus target is less than the absolute value of closest sum minus target, then closest sum equals S. Otherwise, you change the upper and lower bounds of the two-pointer thing based on whether or not it's too big or too small. And then this, we can actually just skip out entirely. We can just change this with return s. Because, actually, why don't we put this after here? Because in the case that we actually return it, then we don't even need to do this. Because the program will have already ended. So, might save us an iteration there if we find an exact match. I think I mixed it up when I was trying to, let's see, we're just going to reset it and then paste it. Okay. Awesome. Okay. Does that work for all of them? And if so, then I'll explain it better. Hooray! It works, and it works in pretty decent time. Okay, so I always like to do that to make sure that I'm not explaining something that's about to not work. So, we sort them, because it's not going to cost us any, because that'll actually, even though it costs us time to sort it, it'll cost us way more time to try to iterate through an unsorted list. Because we can infer a lot of information based on it being sorted. We take the first value in the upcoming iteration of the three different values, and we set that to be the closest sum. Just, whatever's first, that's immediately the closest sum because it's the first one. All right. Then we iterate through the first number in the array, and we go through the range up to length of nums minus 2. The reason why we do minus 2 is because this is exclusive, and we need to have two, the upper bound is exclusive, and we need to do minus 2 to offset for the two remaining values that we would need to create the three value sum. We can skip through I if I is already, if I was the same as the previous I. Otherwise, we set the L and R bounds, and then we lower R if the sum of I, L, and R is too big, and we increase L if the size of L is too, if the sum is smaller. So we're essentially just converging it in the right direction. And this will basically delete a lot of the iterations that we know for a fact couldn't be the solution. Because if we have three numbers and those add up to a number that's too small, we know that we can't just increase one of the numbers and expect it to be any closer. I think we can actually do one step better. We can actually steal this from the prior loop. Or can we? Nah. I don't think so, because the behavior is just a little bit differently. Anyway, that's all there is to it. It's a really good puzzle. Yeah, thanks for watching. See you later.